Welcome to another tutorial of the thermal system design class. So in these tutorials, we're gonna solve a specific problem using all the tools learned from previous tutorials. So if we take a look, here is a problem. So we're gonna solve for the laminar flow over a heated cylinder. We have our conditions. We have our working fluid is gonna be air. The cylinder diameter is gonna be 2 inches. The cylinder wall temperature is 80 degrees Celsius. The inlet velocity is the Reynolds number is 100, which is laminar flow. The inlet air temperature would be 25 degrees Celsius, and we'll be solving for three different contours: the velocity, the temperature, and the pressure. We're gonna plot the velocity, the temperature, and pressure as well at the diameter, at 2 times the diameter, 3 times the diameter, and down the stream of the location, we're gonna calculate the surface heat transfer coefficient, the average nozzle number, and the total heat transfer. So we're gonna use a very similar geometry as the one that we created for the 3D problem, but in this case, our diameter is gonna be a 2-inch diameter. The center of the cylinder is gonna be 20 times the diameter away from the edge, and our length is gonna be 30 times away from it, so it's gonna be 60 inches, and it's gonna be 40 inches in here. So as we can see, it's gonna be, this cylinder is not gonna be at the center. The height of the domain is gonna be 30 inches. We have here the length of the cylinder is gonna be 10 inches, and the extrusions that would be necessary to create the domain. So first of all, we select fluid flow fluent, and we'll go to design modeler. Once we're inside of design modeler, we select our units, which are going to be inches. We go to our plane, we create a new plane, we look at it, we will create our circle from the center, dimensions. You can either click vertical, or you can click on general, or you can click on diameter. It's gonna give you the same thing. General is just gonna recognize that this is a simple circle. I'll set up as 2 inches. Go back to modeling. We generate it. We click on extrude. We select the geometry. We add frozen. And this cylinder is gonna be we're gonna say that this cylinder is both symmetric, so it's gonna be 5 and 5 inches in order to be 10. Generate it, take a look at it, and this is our cylinder. Pretty straightforward. We create a new sketch. This is gonna be a rectangle. Create a simple rectangle. Dimensions, general. We click on the length and the height. Our vertical, this is supposed to be 30 inches. So it's 30. And this is supposed to be 60 inches. 60. We create a horizontal distance, so it's from the center of the circle this is supposed to be 40, and then we create another one vertical from the center of the circle to the bottom and the top. This one is supposed to be at the middle, so that's gonna be 15 inches. We have created our domain. Go to sketch, we generate a sketch, we go to extrusion, select our plane, we add frozen, both symmetric, it's gonna be 30 inches, so 15 and 15, generated, and we have created our domain with our cylinder. Remember that we'll have to go to create boolean. We're gonna subtract the targeted body that we want is the domain, and the tool body that we're gonna remove is gonna be our cylinder. We generate it, and here we have our domain. Pretty straightforward from what we've seen. And we'll close this. We'll go to meshing. Our geometry is gonna start loading. And here we have it. We look at wireframe. We click on matching. We just generate the default fluent linear. Let's create an adaptive sizing. Let's make it a 5. Let's update our meshing. Let's see how many elements we have. We have 55. We can make our geometry, our meshing a little bit more fine. So there we have it. Let's look at it in the wireframe. And let's create also an inflation point. So from last time, we know that we have to create these inflation points in order for us to have a better representation of the velocity profile. So we have here our cylinder. We don't have an inflation layer. So to fit, we go to insert. We create an inflation. So our geometry, that's gonna be our entire domain. And our boundary, that's gonna be, we try to look at the cylinder. We select the cylinder, we go back to inflation, we apply it. Let's create 10 layers. We generate the mesh. Apparently we have too many elements. So let's reduce this resolution a little bit, just to make it a little bit better. And we take a look again to our section plane. We can see the layers at the can also change our meshing from just linear to quadratic. And there we have it. We have a more structured mesh, which will be better for our simulations. So we go back. And remember that we have to create our name selections. Let's go to wireframe, select faces, select this face, create name selection. This is going to be our inlet. Okay. This other face is going to be our outlet. If we select control and we click on the different faces, we're going to select all of them. I selected the other ones. I apologize. Let's select these faces again. Create a name selection. Let's call this symmetry wall, so we don't have any viscous effect at the edges of the domain. And lastly, cylinder wall. So from here we have created our problem in order to start setting it up. In the next tutorial we're gonna go into the setup, and we'll keep on working on this problem until we get those solutions.